typically we'll use vectors to do things with the motion of something. The typical problem in calculus is the motion of a particle. Particles are not really existent. They're kind of idealized. But it could be the motion of a planet. It could be the motion of a car. It could be the motion of a person. Usually we use particles just to keep it simple. So there's a few different types of vectors we're going to use here. We've got a position vector, which is what we just looked at. The position vector, I'll call it R here, but it doesn't have to be R. That's just the x and the y components. And so they're going to be functions of x and functions of y when we talk about the position vectors. The velocity is the derivative of the position, right? So to find the velocity of a particle, all we have to do is take the derivative of x with respect to t and the derivative of y with respect to t. So the velocity vector is just going to be dx dt, comma, dy dt. The speed is going to be the magnitude of the vector. And so since we're talking about x and y, as functions, then to find the magnitude of those functions, we would take the derivative of x with respect to t and the derivative of y with respect to t and plug it in here. And so this would be the magnitude of this vector right here. Where have we seen this square root before? Yeah, if we integrate that, that's the curve length of a parametric equation, right? So if we integrate the speed, that's going to give us the length of the curve. So that we've seen that square root before. The acceleration vector is exactly what we would expect it to be, because acceleration is the derivative of velocity. So if we take the derivative of this component-wise, take the derivative of dx dt, we get the second derivative of x with respect to t. Take the derivative of dy dt, we get the second derivative of y with respect to t. And then the direction vector is going to be the vector itself divided by the magnitude of v. Now, the magnitude of v, that's just a number, right? That's not a vector. It's called a scalar. So what we're doing here is we're going to take the vector itself and we're going to divide by the length of the vector. And when you do that, you get a direction vector. So it's a vector that just tells you what direction it's going.